Imagine generating electricity from fossil fuels without harming the environment. Some 40% of the world's carbon dioxide emissions from the energy sector are generated from power stations that use fossil fuels, oil, gas, and coal. Carbon dioxide emissions are now widely accepted as the main contributor to climate change. We believe generating electricity. The Hydrogen Energy California project will utilize petroleum coke, a byproduct of the oil refining process, supplemented by coal when necessary. Heating these fuels to high temperatures and pressures turns them into a gas, which then goes through a cleanup process to remove substances such as sulfur. It is then split into its two component gases, carbon dioxide and hydrogen. The carbon dioxide is captured, compressed, and transported via a pipeline, then injected deep underground to be stored safely and permanently. Injection would be into oil fields, where it would enable additional oil reserves to be flushed out. The carbon dioxide remains behind to be stored on a permanent basis beneath a natural impervious seal. Meanwhile, the hydrogen is used as fuel to generate electricity, with a reduction in carbon dioxide emissions of some 90%. Hydrogen is a clean, versatile fuel of the future, and the technology that produces it will take us one step closer to a hydrogen economy.
Anschließend Kohlendioxid als Treibhausgas ausgestoßen wird. Dabei ist eine sehr gute Lösung die Verwendung von Wasserstoff als Energieträger, den man vorzugsweise in einer Brennstoffzelle elektrochemisch direkt in Strom umwandeln kann und damit eine gänzlich CO2-freie Mobilität auch für Fahrzeuge gewährleisten kann.
And that's without sacrificing engine power or mileage, as well as making it faster and simpler to refuel. Hydrogen was discovered in 1766 by a British scientist named Henry Cavendish. He stumbled across the discovery that water consists of hydrogen and oxygen. Hydrogen comes from the Latin hydrogenium, which literally means making water. This is why the chemical symbol is H. Hydrogen is the first element in the periodic table, and not for nothing. No other element is lighter. No other element is more abundant in the universe. Hydrogen is pure energy. Perhaps the best example is the sun, which is 92.1% hydrogen. On Earth, hydrogen only exists in its molecular bonded form. In order to produce pure hydrogen, you need to separate these elements. This requires a great deal of energy. One method is electrolysis, where electricity is used to split water into hydrogen and oxygen, an expensive and energy-intensive method. This is why OMV employs a widely used method to produce hydrogen, steam reforming. Here, steam is introduced to a fossil fuel such as natural gas and heated to 830 degrees Celsius. Pure hydrogen is then extracted from this mixture via a multi-step process of filtering and cleaning. This is currently the most efficient way to generate hydrogen.
In einer Brennstoffzelle dieser Energiewandlung, die darin stattfindet, deutlich höher als die von einer Verbrennungskraftmaschine. Und natürlich durch diverse Zusatzteile, die man benötigt, erreicht man aber auch im realen Fahrzeug eine deutlich gesteigerte Effizienz gegenüber den klassischen Antriebstechnologien, die man kennt.
Vehicles with fuel cells are already in use, although only in an industrial context, such as at the logistics company DB Schenker in Linz.
Dort fahren die Hubstapler mit Elektroantrieben.
At the moment, there is only one car powered by fuel cells on the road, an OMV research project. This has also seen Austria's first public hydrogen filling station open in Vienna.
Wasserstoff in der Mobilität ist ein neues Produkt. Richtig einen Schwung bekommen wird das erst rund 2025, denn dann werden fast alle Automobilhersteller sogenannte Null-Emissionsfahrzeuge brauchen, um ihre CO2-Vorgaben zu erfüllen. Geplant ist in Deutschland in den nächsten 10 Jahren rund 400 Tankstellen zu bauen.
But this transformation will only succeed if customers are happy and can fill up in the way they're used to.
Die Preisgestaltung beim Wasserstoff ist heute Benzin oder Diesel.
OMV already produces 100,000 tons of hydrogen each year. This is enough to power every car in Vienna for a whole year. It is sufficient energy for 850,000 cars. And in the future, it will be possible to produce hydrogen using alternative local energy sources. The future will see a huge rise in the range of applications for hydrogen. The energy it provides can now be used on the road via a fuel cell system. Each fuel cell consists of 2 plates separated by a membrane. Oxygen from ambient air is supplied to one side, with hydrogen on the other. The positive particles of the hydrogen atoms are able to pass through this membrane. The negative particles cannot pass through. However, atoms need an equalizing charge. To achieve this, the electrons must change path, and this creates an electrical current. The end products from the chemical reaction are power for the drivetrain and H2O, that is, pure water. This is the only emission produced by this mini power station.
The original A-bombs, like the ones the US dropped on Hiroshima and Nagasaki, worked by splitting the nuclei of heavy elements into smaller ones in a process called fission. They used either uranium-235 or plutonium, which, when split, released neutrons that split more atoms in a chain reaction. The resulting elements have a smaller total mass than the original. So, where did all that missing mass go? Well, if you remember Einstein's equation E equals mc squared, you know that energy is equal to mass times the speed of light squared. This means that a tiny amount of mass is equivalent to huge amounts of energy. If you're making a weapon, this principle means the amount of uranium-235 you can fit in a coffee mug packs the same punch as 20,000 tons of TNT. But A-bombs leave a lot of atomic fuel unsplit, which is where hydrogen bombs come in. An H-bomb detonation starts the same way an A-bomb does. Uranium-235 or plutonium is split, releasing tons of energy. However, right next to the A-bomb primary is, you guessed it, hydrogen. More specifically, deuterium and tritium. Deuterium is a stable hydrogen isotope with 1 proton and 1 neutron, and tritium is also an isotope with 1 proton and 2 neutrons. The 2 isotopes can be smashed together to form helium in a process called fusion, like what happens in the core of our sun. But that only starts to happen at 15 million degrees Celsius, hence why these devices are called thermonuclear bombs. The X-rays from the exploding atomic bomb have enough energy to implode the hydrogen, and they travel at the speed of light, so they get to the hydrogen before the shock wave blows the bomb apart into less deadly chunks. Of course, the fusion fuel produces plenty of energy itself, but it also produces more free neutrons, which can be used to make the fission more efficient. For this reason, the H-bomb is often wrapped in a tamper of more uranium-235, meaning it explodes in stages of fission to fission again, like a turducken of Armageddon. Theoretically, it could have several stages, and designs with up to 7 layers have been drawn up, but eventually, what's the point? I mean, just how dead do you need to make something? The largest man-made explosion ever was a 3-stage hydrogen bomb, the equivalent of 50 million tons of TNT, called Tsar Bomba. I'll let you guess the country. So, hydrogen bombs can be thousands of times more energetic than atomic weapons, which North Korea has already tested. And since they deliver maximum bang for their size, H-bombs can be more easily fit on a missile and devastate a city.